Okay, welcome everyone. This continuation of the behavior change science, what do we call this? A meetup series that's organized by the University of Tampere, the behavior change and well-being group in there. And so I'm going to talk about this topic that's well, we will see. It's probably not that behavior, what you're used to if you're in behavior change, which is sort of also why I'm interested in that, because I usually pursue topics that uh, are sort of a bit adjacent to the mainstream, but I hope it has enough touch points for you so you can sort of keep up and find points of connection to your work. A little background from me. So I spent a decent bit of time in Nelly Hankonen's research group in University of Helsinki, which, as mentioned, is now in the University of Tampere. I've spent some time in the Finnish Prime Minister's office behavioral science advisory group. It's called Finnish Behavioral Policy Group now. One of the more exciting projects that recently finished was called Citizen Shield, where we studied pandemic preparedness. And I have a sort of a knack on this preparedness sphere, and particularly in complex systems. And I also do a course a couple of times a year in the New England Complex Systems Institute, where I'm co-faculty. And I'm also a trainer in the Finnish 72 hours household preparedness concept, which interestingly the EU now made a strategic priority in the beginning of this year. And I'm really much of my research now is focused on trying to figure out, okay, so how do we accommodate everything that's between the institutional level and the individual/household level, all the networks through which people make sense of official guidances and also support each other in this endeavor to prepare for the interesting future that we have in front of us. We just landed one project called, so it's called SMARTS with Jyväskylä University about hybrid and remote work. You can find more about that online. And my main work is taking place in a medical faculty in the University of Heidelberg. So it's a preventive medicine research group, and the sort of why they became interested in these sorts of crises and emergency preparedness was that in Germany you can really feel the climate change nowadays, as there's a lot of these heat waves, and people wanted to prepare for heat waves, and then realized that many of the same principles that go to preparing for heat waves also pertain to all kinds of emergencies, from electricity outages to pandemics to misinformation, even hybrid warfare, and so forth. And I wanted to start this actually from a story about the electricity outage. So this is a electricity grid supplier in the Iberian Peninsula, and they announced this. They made this announcement saying that there exists no risk of blackout. Red Electrica guarantees supply of electricity. And as it happens, so this was April 9, and this news piece is from April 29, when almost all Portugal, Spain, and parts of France sort of plunged into a blackout. And now this was a surprise to some, but not all. If you've heard of the concept of black swans, a black swan for a terrorist is a black swan for a preparedness planner is not a black swan for the terrorist. And some people had been calling this risk out, which is why they actually sent out this communication that there is no risk. But the reason that some people were able to sort of say that this might be something that can happen, well, there was were signs in the industry itself, but also electricity grid outages, they follow this particular distribution that's best illustrated by ladders. So bear with me. So imagine you have, so here you have 6 ladders. And if each ladder is independent of every other ladder, the risk, let's say risk of one ladder falling down is 1/10. So let's say it's 10%. So the risk of 2 ladders falling down would be 10% times 10%. So 1%. Risk of 3 ladders would be 0.1%, and so forth. And if you had 100 ladders on a wall, the probability of that all of those would fall down at the same time would be like astronomically small. But then imagine that you do something different. So you tie a rope across these ladders. And by introducing this rope, you introduce interconnectedness. So you make these ladders sort of a more safe in the way that there's less chance of any single ladder falling down. But now you have introduced a non-negligible chance that all of them would go down together. And this is sort of what interconnectedness does. And there's a lot to talk about. So in my YouTube, I have actually a Finnish video that explains why how the world's increasing interconnectedness has led to the dismantling of these hierarchical organization structures in favor of network cooperation. But we can sort of take this idea of the ladders to sort of very roughly divide the world's risks into 2 categories. So on the one hand, you would have these modular risks, and we would call them also like thin-tailed, because so I will show you some distributions a bit later on, but what the thin tail means is that if you have a bell curve, the curve has sort of, it has tails, and it has shoulders, and it has a bulk of the distribution. And in the thin-tailed case, the tails are very small, which means that you have very few extreme events. And this comes very naturally from the fact that these things interacting in this system, well, they're not interacting, they're independent. And in these sort of modular risks, they don't endanger the whole society or cause cascades. So traffic accidents would be one example. So you wouldn't have, so if you have a traffic accident in Helsinki, it would be pretty much impossible for it to have a huge effect in Pärnu or Stockholm, or even somewhere like Heidelberg. But on the other hand, if you have these cascade risks, which are sort of the other risk category, where the tails are much fatter than and thicker or heavier than in the case of the normal distribution, where you have the independent components, then you can enter a world where you have actually existential threat, because these domino effects can go around the world even very rapidly. Pandemics being one example of this. And so if you've ever heard of the concept polycrisis, that's also part of the our modern society where we live in, because these risks can sort of cascade and launch and trigger other risks, and then we have very nice things that can come out of interconnectedness, but we also have these certain risks that can come out of that. And so in the case of modular risks, if something hasn't happened in 50 years, it probably never will, because if something that's quite extreme, you might, if you have an like a normal distribution and you have like a thin-tailed distribution, then it's almost impossible to have these very extreme events. Whereas if you're in the world of cascade risks, of interconnectedness, if something hasn't happened for 50 years, it might just be that we've been lucky, and the event, when it happens, it might actually be like astronomical in size. And I will show you some examples soon, but first I wanted you to take a sort of a moment to pause and maybe write in the chat and think about these couple of examples. So we did this training for civil servants on complex systems and behavior change, and so this was one of the things that we also taught in that course. And so, but first let's talk about like workplace injuries. If you want to put in the chat, like, is this a cascade risk or a modular risk? Who's bold enough to start? Yeah, modular most of the time. Yeah, exactly. It depends. If the workplace injuries, if they are sort of caused by a some systemic phenomenon, maybe in that case it could be a cascade risk. But almost all of the time, if someone falls down a ladder from a ladder in one construction site, that doesn't influence someone else in the nearby construction site. And then we have the next one is street violence. What do you feel about this? Modular or cascade? Yeah, and I might say for this also that's it's a modular risk. If there is something, again, something systemic going on, like a new kind of a organized crime or something that causes it, or like these riots because of food shortages and or climate migration or something like this, it might be different, but those are sort of different causes that like everyday street violence and street safety that we call in Finnish, we have this concept called arjen turvallisuus, so like everyday safety and security. It's quite modular, so it doesn't tend to spread. But then you have again like a third example of a nuclear plant accident. And I'll let you have a small time to think about this before, as I always say, it depends. And in this case, most modern nuclear reactors are built such that you don't have one huge reactor, but you actually have many small ones. And in theory, the explosion of one reactor should be dependent of the other reactors. But then there is this mathematician Rafael Duadi who said in the Real World Risk Institute course that it doesn't help if all your eggs are in different buckets if all the buckets are on board the Titanic, which is sort of what might have happened in Fukushima, for example. So it depends. Maybe mostly not. A novel pathogen, I kind of gave it away already when I talked about pandemics, but so we're sort of expecting when the polar ice is melting that there will be these bacterial plagues waiting for us that can be sort of very cascading of cascading nature. And then war is one of the most fat-tailed phenomena there is. And there's an interesting paper here that basically showed that if you have this air travel and you have a simulation model and you increase the amount of global air travel, and you look at, okay, so what happens when some novel pathogen emerges, then at some point you reach a tipping point where it becomes like hugely more. So if this interconnectedness by air travel is increased to a particular point, then it becomes hugely more probable that there will be an extinction level event that wipes out both the novel pathogen and its hosts, in this case humanity. Ain't that fun? Some articles about war and diseases, so yeah, good stuff. Okay, so we have these sorts of two risk categories, and one of the important things is sort of to understand which category am I in? The thing that I'm dealing with, where does it stand? And the issue sort of is that these modular risks, because there's so much more, the typical risk is so frequent and basically almost a non-event. They're quite easily imagined. There are many typical precedents, and they sort of change quite slowly. So if you think about like non-communicable diseases, it's not that they could just suddenly explode one year after another, but the trend has been slowly creeping up. And so in this case, we can sort of use this evidence-based risk management because evidence is often thought of as data, and empirical data is data from the past. And if the past is sort of like the future, then we can quite nicely learn from the past and do things a bit differently in the future, maybe. But the problem with these cascade risks is that because we don't have the huge events that much, they're not sort of visceral, they're not proximal, and you don't often get political points very generously if you prevent something that people are not even conceiving of as a risk, and people sort of respond to proximal risks, not distant ones. And you tend to have like a few of these, well, the typical precedent of is normally it's quite not a huge event. And sort of you can have these huge events and small events, but little in between. And I'll show you this in a moment. But in this sense, you don't really want to learn from errors because you might not be there after conducting the error. So you want to sort of anticipate or avoid the experience altogether. And so here's an example from the case of pandemics. So you have year in the horizontal axis, and you have the casualties rescaled to contemporary population. in the vertical axis. And so here you have, for example, you have Black Death with something like 2.7 billion deaths in contemporary terms, like looking at the proportion of world population, it diminished. And then you have this histogram on the right, and you can see that there are super many, super little events. So these are like 1 or 2,000 casualties. And then you have few of these sort of kings that are almost as big as everything else combined. And then this dotted line is the mean, and you can see that the mean is actually can be like 10 times or 100 times more than the sort of typical event. And then here we were talking about billions, but if we just cut off this chart through here and forget about these big boys, and we look at the scale of millions. So we have Antoinian plague that was here, now it's here. Spanish flu came to here. And then you still have a similar distribution. You can make out the sort of mean versus typical line a bit better, but you still have this thing where you have lots of sort of very small events and then fewer of these very huge events. Now compare this to the annual casualties from road traffic. And what you see here is, so you have the deaths on the scale of like, it's less than 2,000. And you would never expect to see a year when you would suddenly have like 10,000 casualties. Even like 3,000 or 2,000 would be like super weird and probably caused by some systemic phenomena, because these are sort of very independent from each other. So you see this clustering in a quite small period, or a small range of the values. And if you only look at the sort of recent ones, so there's this trend going down. And so this is the independent case. This is the thin-tailed case. You don't have, this tail doesn't continue somewhere here. And here you have the ladders that are connected with the rope. So contagion, cascade going on. And this is a generalization from all of that. And so what I call cascade risk can also be called like heavy-tailed, and this is thin-tailed, the modular risk. And I want to draw your attention to 3 points of this chart. Okay, so the more to the right you go, the bigger an event. So you have very few super big events. You have a lot of small events. But now the difference between the independent and the cascade risk, the first difference comes from here. That actually in the case of the cascade risks, you see a lot more sort of these super small cases, super small, like non-events. There are so many of the non-events that you're like, okay, so is this thing even, why should we consider this a risk? And then, but it goes down very fast. And then in the body of the distribution, here, you see the difference that the independent case has many more mediocre events than the heavy-tailed ones. But on the other hand, and here is the zoom of this end of the tail part. So for example, in at this point, you have actually already like a double the amount of events for the heavy-tailed case than in the thin-tailed case. And eventually, or very quickly, the modular risk, the probability of having an extreme modular risk goes to 0, whereas you retain a non-negligible risk of a super big interconnected cascade risk. And I will show you the empirical version next, but just to point out that if you put these things on a log-log scale, you have, you see the body of distribution, so the difference here, that's what you see here. But then what happens is that in the thin-tailed case, the extreme extremes sort of, it drops very quickly down here, and the cascade risk, it goes in a straight line. And to put that in context, here we have again the pandemics and the traffic deaths in a log-log scale. And you can see that I can draw a linear regression line here. And we expect the next, like it's not, there is a non-negligible probability that an event that occurs somewhere here. So it's possible. Whereas in this case, you see what you just saw with the line going down, just as we would expect based on the statistical distribution, the traffic deaths. It doesn't fit. So I'm drawing this curve based on the data for the same portion, and it doesn't fit this the shape of this the empirical data at all. So what happens is that it goes very quickly down, and we expect the next extreme event to be very near somewhere of this previous extreme. Whereas in this case, the previous extreme can be quite minuscule based on compared to the next extreme that we have not observed yet, because it hasn't become a reality, but it's something that's sort of possible still. And so now from a decision-making perspective, so from a policy perspective, what you have here is these modular risks. So you have many small events, and they're quite homogeneous. And as I mentioned, they are sort of, you can learn from them because they're in a different way. They are like each other, and you have many examples to work with. And here at the cascade risk world, so this is the line that goes straight here. So this same line represents the same thing that happens here and happens here. And so this is the size of event, this the size of the circle. So if the future is not like the past, you can't use past data to learn for the future, but you must do this sort of anticipatory work. So here you can extrapolate from past data, and here you must sort of form these plausible hypotheses from the current signals that might be weak signals, quite incomplete. And so in order to work your precautions, you want to catch these signals early as they start taking place, because if something ends up growing exponentially, it can sort of become very uncontrollable unless you catch it early. And yeah, so here is the modular ladders, and here's the interconnected ladders. Okay, so what we've been doing in Germany now is setting up this network of participatory community surveillance partners, who are like individuals responding to surveys regularly. And the basic idea is that you would sort of involve the communities in this weak signal detection. And so, first of all, you need sort of the network of trusted survey respondents. And this has been done in many organizations also, so using this sort of whole of workforce engagement to get like a better idea of the landscape of risk and opportunity in organizations. You collect these experiences, And then when a crisis hits, you can sort of pivot to change the function of this network, not to provide you the normal data it does, but to understand how you can help people on the ground. I will give an example of this next, but so one of the important functions also is recording learnings during the process, because what we want to do is avoid this sort of retrospective coherence, because people are not cameras. Our memories are always sort of built and rebuilt. And we might end up doing this, or what often happens is we do this post-emergency sort of learning process, but people's sort of experiences are already tainted, and they remember things not as they happened, but what they remember is affected by the narratives and everything that came afterwards. So we want to also have this data set that allows us to think about, okay, so what could we learn from people's response, actual response and thoughts and so forth during this emergency. And it's not that you can learn nothing from the past, because many of these emergencies or disruptions, they sort of it might be possible, even if the phenomenology of it appears in a different way every time, but something like mutual aid networks and so forth that is relevant for many different kinds of emergencies. So one of the things that we started doing in a Finnish town is building this sort of inhabitant developer network, and the idea came from the wish to increase sort of citizen engagement, because it was recognized as also a very important risk management function, given that people who feel ownership about their living area, they use less healthcare services, they vandalize common property less, and are more difficult to recruit into hybrid or criminal activities. So we have this every time someone comes in the town, they get a welcome to town package. And so that could be used to sort of recruit the people who move in to this developer network, and also recruit old like existing inhabitants from existing channels, use this to build engagement and trust across the board. And so this could, for example, provide this data where you ask people about experiences, like, okay, so what's better here than where you lived before? And you can relate those things to the marketing department, and what's worse here than where you lived before, and you can start using that as stimulus for development projects. And so this would be sort of the ideal would be that this network produces usable data that is also interesting to the inhabitants or the workforce in normal times. And then we can pivot when, if and when a crisis takes place. So this is something we developed for that. So when a crisis would occur, we would take this network and we would ping them. So the same network that could in normal times respond with thoughts about, okay, so what do you think about this policy proposal or whatever? Now we would ask them like, okay, so what happened? How did this crisis or this emergency, how has it affected you and the things that are important to you? Give an open field, and then people can sort of self-index these responses with, okay, so how well did you do during and after the situation? How prepared were you? So this gives us quantitative data that's contextualized by the qualitative data. So you could use this to, for example, filter responses where people were not prepared but did well, were prepared but did poorly, and tagged the experience as having something to do with the emergency services or city officials or whatever, and then we could sort of when people have this opportunity to index their own stories and experiences, we're also following a principle of something called epistemic justice. And then if you have this sort of data, it's also a very nice tool to use in different citizen engagement situations or workshops, for example. So it's a very easy question for people to answer, like, okay, so how could we get more experiences like these and fewer like those? And this sort of is part of a set of complex systems facilitation methods that aim to bring agency of intervention development to communities and workforces themselves. So to sort of wrap up, so what we want to do is we want to first understand where we are. Think about, okay, so is this tail, does it sort of go down or does it go straight, which gives us an indication. And there are many other visualization tools to sort of understand which sort of situation are we in. Is this a modular risk or is this a potential cascade risk? We can develop these adaptive interventions based on the community responses, and the communities can do that agentically themselves. We can, and this sort of gives us the legitimacy and buy-in for those interventions because they live and are engaged by the communities themselves. And it sort of provides us with this real-time data flows from the communities to the decision makers, and hopefully also back in order to have this sort of a conversation instead of a broadcast on policy ideas. And that's all I have, and thank you for bearing with me.
Thank you so much, Matti. Maybe we can stop the recording.